Welcome to the deep dive. Today, we're taking a close look at something pretty interesting at the crossroads of IT and AV high-density video distribution. Our sources are focused on these 4K 30 hertz AV over IP matrix switchers, specifically the kind you'd see in setups with, say, 20 or more TVs.
That's right. And the real mission here is to get our heads around a big shift in technology. We're really moving away from those, traditional big, inflexible hardware matrices, the ones that cost a bomb and had fixed inputs and outputs. And we're exploring how standard networking gear, the stuff running email, is now handling huge AV loads. We're looking at the features, the flexibility, and some important trade-offs in these systems, often called this WolfPack architecture in the source material.
Okay, WolfPack. Good to have a term for it. It sounds like it's all about flexibility using, well, standard bits and pieces. And you mentioned a core design nugget right away, before we even get to performance.
Yeah, it's kind of brilliant for inventory. Usually, you'd buy specific transmitters, TX units for sources, and specific receivers, RX units for displays. Here, the whole system uses just one type of extender hardware, one physical box, and you just tell it via software whether it should act as a TX or an RX.
Wow, okay. That is actually a huge deal. It's not just a tech feature, it changes how you plan and stock for a project, right? No more ordering nightmares, counting TXs and RXs, you just grab a bunch of these universal extenders.
Exactly right. Fewer product codes, simpler installs, and loads more flexibility on site. Need to swap a source and display location, just reconfigure the box in software. That adaptability is really central to this whole AV over IP idea.
Okay, right. So let's unpack the tech foundation a bit more. We're talking 4K video, commercial scale, running over standard networks. What are the hard specs making this possible?
Well, you got to look at the constraints first. The tech is specifically 4K, but at 30 hertz. 4K 30 hertz AV over IP, and it uses PoE, power over Ethernet. And crucially, it's designed for a standard 1 gigabit Ethernet switch.
Hold on, standard 1G? Like the same switches used for regular office data?
Precisely. And that decision kind of dictates everything else. A 4K signal, uncompressed, needs way more bandwidth, like 6, maybe 12 gigabits per second. Pushing that through a 1 gig pipe means you absolutely need serious compression. That's why these systems rely heavily on H.265 compression. It's very efficient.
Gotcha. So the 1G switch is the bottleneck, or the design choice, really, and H.265 is what makes it work. That also explains the 4K 30 hertz spec, not 60 hertz. They're squeezing the signal to fit the bandwidth.
That is the trade-off, yeah. You accept 30 frames per second, which is fine for a lot of content, to get the huge cost and scaling benefits of using standard 1G infrastructure.
And the wiring, is that standard too?
Yep, standard QT6 cable, easy to get, reliable. And the power over Ethernet makes it even simpler. That one CT6 cable carries both the video data and the power for the extender unit. So no need for power adapters at every TV and source location. Plus, you can run it up to 450 feet, which covers most big spaces pretty well.
Yeah, POV is definitely a win for installers. Less clutter, easier runs. And the sources mentioned a specific example, right? A 14 by 32 system.
That's right. So 14 sources going to 32 displays. That would need 14 extenders set as TX, 32 set as RX, and then just one or maybe a few stacked PoE Ethernet switches managing it all.
Compare that to an old school 32 by 32 matrix. That would be a massive, super expensive custom box.
Exactly. This way it's broken down. Lots of smaller, cheaper, identical units managed by standard network gear.
So let's talk scaling. The sources make some pretty bold claims here. Things like unlimited sources, unlimited computers, unlimited HDMI ins and outs.
Well, that's the promise of IP, isn't it? You can add an IP address, you can add a device. So theoretically, it scales almost indefinitely, limited mostly by your network's capacity and how you manage the addresses. The core idea is definitely any source to any display, however you want it.
Unlimited is a strong word, though. Is there a practical point where managing all those cascaded switches just becomes, a massive IT headache? Are we just swapping one kind of complexity for another?
That's a really good question. And it's key for the integrator. The hardware might be simpler, cheaper, but the system now really relies on good network design. You need proper VLANs, multicast configuration, enough switch backplane capacity. That all falls on the network side. So yeah, the cost shifts from expensive AV hardware maybe towards needing stronger IT skills or network management tools. The limit isn't usually the number of boxes, it's the network backbone and budget.
Okay, let's pivot to performance. This is probably where people get skeptical. 1G network, heavy compression, sounds like lag, doesn't it? What do the sources say about latency?
Yeah, you have to address latency head on.
Yeah.
The spec sheet says 80 milliseconds for both pushing time and overall latency.
80 milliseconds. In the video world, you'd notice that, wouldn't you? Like for gaming or maybe fast camera switching, 80 meals isn't instant. So that brings up a big question about where this fits. What kind of professional environment finds that trade-off massive scale for, let's call it, moderate latency acceptable?
Yeah, you need to think about passive viewing versus interactive use. 80 milliseconds is roughly, what, 2 or 3 frames at 30 hertz. So you gain the huge cost savings, the flexibility, the scalability, but you give up that near instantaneous response. This kind of system is really ideal for places like sports bars, digital signage, airport FIDS screens, menu boards, waiting rooms, places showing content, not requiring immediate user interaction with the screen content itself. These places value flexibility, cost-effectiveness, and stability more than they need subframe latency.
Right, that makes sense. So a casino showing betting odds on hundreds of screens or an airport with departure info everywhere, the cost saving and scale wins out over the slight delay.
Precisely. But if you were designing, say, a high-end command control center where an operator needs instant visual feedback across multiple screens when they click something, you'd probably still look at more expensive, maybe uncompressed, maybe fiber-based systems. That 80 meters figure clearly positions this technology in that high flexibility, commercial signage and distribution space.
And the pricing seems to back that up. You mentioned the individual transceiver, the universal box, is only around $250.
Yeah, about that. And the example systems, like a 4x12 setup, come
What?
in under $5,000. Even a 10x20 system is listed around $9,000.
That's dramatically less than traditional matrix solutions for that kind of I/O count.
It really is. By leveraging standard network hardware, it lowers the barrier to entry significantly. The complexity and a chunk of the cost shifts from specialized AV gear to more general IT networking.
Okay, so moving beyond just the switching,
Yeah.
once the video is just data packets on the network, what kind of cool features get layered on top? What does the software enable?
This is where it gets interesting, yeah. Because it's network controlled, you get powerful software features. Like the system supports video walls natively, and they claim you can build any size, any configuration of video wall using these standard extenders. That gives designers huge creative freedom.
That's huge for retail or big public spaces. But managing all of that, if you have dozens of screens, how do you even know what's playing where?
Centralized control is absolutely essential. One key feature mentioned is an iPad app that gives you a real-time video preview of all the sources. So a manager can just glance at their tablet and see exactly what's feeding into the system without running around. Plus, it supports 4K 30 Hz live streaming. So the video being switched around can also be sent out live for monitoring or recording elsewhere on the network.
The sources also mention some pretty advanced control features, especially in an optional package, something beyond just HDMI switching.
Right, they talk about an optional sports bar system software package. This is where it gets really integrated. Because it's all on the network, the control system can actually talk to the source devices. So this sports bar software lets the user change channels directly on DirecTV boxes, DISH receivers, cable boxes, even Roku, all from the main control interface.
Whoa, okay, so the matrix system becomes like a master remote control for the whole venue sources too.
Exactly. You're managing the content source and where it goes all in one place. And the interface sounds pretty slick, too. It apparently shows the facility's floor plan visually, lets you tap on a TV to control it, shows TV listings, handles audio zones, and you can control it all through Wi-Fi apps on iOS, Android PCs, or dedicated Windows software. It ties everything together.
Okay, let's wrap this up by looking at the business side. What about ongoing costs? Compliance issues, anything users need to be aware of when moving to an IP-based system like this?
Good points. On the financial side, the source material is very clear. There are no monthly license fees, which, in the world of enterprise software, is a really big deal. Subscription costs can add up massively over time, so that's a major plus for total cost of ownership.
Definitely a big selling point. And compliance,
Yeah.
security, copyright protection.
It's also covered. The system is listed as SEC security compliant, which is important for financial institutions or anywhere data security is paramount. And crucially, it's HDCP compliant. That's the high bandwidth digital content protection. It means it meets the standards needed to legally distribute protected content, like from Blu-ray players or cable boxes across multiple screens.
Good. And the company behind it, HDTV Supply, they've been around a while.
Yeah, the source mentions they're a 24-year-old company, certified since 2003.
Hmm.
So there's a track record there, which adds a layer of confidence when you're relying on their tech for your whole AV setup.
Right. You want stability when your infrastructure depends on software.
Okay, this has been a really insightful deep dive. We've seen how one flexible hardware unit combined with standard 1G networking creates this super scalable, feature-packed video matrix alternative. The simplicity from PoE, the unified TXRX, the powerful software control, it really feels like a significant shift in how these large video systems are built.
Absolutely. And I think the key takeaway for you, the listener, is really about how this shift impacts possibilities. High-end, large-scale video setups are now riding on the same rails as everyday data traffic. That changes the economics completely. But remember that trade-off. You accept the 80 milliseconds of latency for that cost saving and flexibility. So here's the final thought to chew on. Network speeds are always increasing, right? 1 gig is standard now, but 2.5, 10 gig are becoming more common. How long until network speeds get fast enough that this latency trade-off basically disappears for even 4K, 60 Hz or higher, potentially making most proprietary AV hardware obsolete outside of truly niche ultra-low latency needs? Where does that leave the future of AV infrastructure?